Let's look at a simple data science machine learning problem, which is to build a regression model using simple linear regression to predict the salary of an employee given his number of years of experience. So obviously we need a data set for this, and here is the data set, a very small mini data set which has around 31 samples. The first column denotes the number of years of experience and the second column denotes the salary. So if you give this data set as an input to the learning algorithm, which is developed using Python, it's right over here. So we will be looking at this learning algorithm. So we give this data set as an input to the learning algorithm. The output will be the model. So we are going to see the model built through the learning algorithm. So what are we going to use? So we are going to use Python for building this model. And the libraries that we are going to use are NumPy, Pandas, scikit-learn, and Matplotlib. First of all, what are the steps of building this model? First, we need to import the libraries, step 1. Step 2, we are reading the data and splitting it into input and output. Step 3 is we are actually choosing 1/3 of data for testing and 2/3 of data for training. And then we select the simple linear regression model from the suite of scikit-learn models. And then we do model prediction using a simple, we just give a single test input and predict the output. Then we visualize the results and then print the testing results. So we have these 7 steps. So let's go over them one by one. So here is the program that actually shows the simple linear regression based on the salary data of software engineers. So the currency that we use is in rupees from India. A similar implementation can be done done in euros or for dollars, right? Now first we import all the libraries. So we import NumPy and Matplotlib, Pandas, and then scikit-learn. The train test split function actually splits the given input into training and testing. And then this is the linear regression model that we are selecting. So this step 1, we import all the necessary libraries. To another point that you consider all of them as libraries, not frameworks, because libraries, you are just using them, but frameworks also gives you the method of how to write your application. So in a sense, these are considered as libraries. So you can see that here we have the data set in a different directory. So we give this directory here. Let's actually put the line numbers. So we give this directory here to this read CSV file, absolute path of the directory, dataset slash salary regression train.csv. So, and then in these two lines, lines 17 and 18, we select the input. So we select all the rows and then the columns only the 0. Till the first column we select, which means only the 0th column is selected as input, and then output is the last column alone. There are only 2 columns. Basically, the first column goes as input and the second column goes as the output. So once we have segregated input and output, now we select 1/3 of the data for testing and 2/3 of the data for training. You can see over here that the 1/3 of the data, rather actually it is 1/4 of the data. 1/4 of the data is for testing and the remaining is for training. So we get 4 outputs here. So the input training data, the input testing data, the output training data, and the output testing data. So you get 4 outputs here based on the proportion we have selected for training and testing. Now we have segregated the input and output. We have imported the libraries. We have segregated the input and output, and we have selected 1/4 for testing and 3/4 for training. We are actually using a regression model. But in that, are we going to use simple linear regression or polynomial linear regression? There are many types of linear regression which we will explore in another video. So we have simple linear regression, and then we have polynomial linear regression, we have non-linear regression, and then we also have multivariate linear regression. So actually the simple linear regression is also called univariate linear regression. And then we have regression with regularization. There are three types of regularization. Regression with regularization. So there are three types of regularization. We will actually devote couple of videos to go into this. So now let's look at the step 4. Here we select linear regression, and then we select the linear regression model, and then we get the parameters of the model, which are actually the default parameters. And then here model.fit does the training with the training input and the output for the training. So because this is a supervised learning model, we have both input and the output that is given as input for the training. Obviously regression is a supervised learning model, so we have to give both the input and the output. Once we actually trained the model, then we are ready for testing in step 5. So as you can see from line number 32, so we are just giving a test input as the number of years of experience, and then it predicts in line number 35. We predict for the particular simple text input for the number of years input, rather the number of years input, we predict the salary. Once we predict the salary, we actually plot the model that we have built. So how does the linear regression model look like? Obviously, the linear regression model, in the simplest term, nothing but y equal to mx plus c. So this is also what Andrew Ng calls this as h theta naught of x is equal to theta naught plus theta 1 x. So which is the same as saying y equal to mx plus c. So here we plot the model that we built. Once we plot the model that we built, then in step 7, we give the input test. So as you can see, input test is an array of test numbers, 1/4 of the data here. So this is the input test, but there is a difference here. If you watch this, while I am calling model.predict in line number 35, I only give the test input. Here I am actually giving a single test input here just for checking if my model is correct. But here I give a complete array of test inputs, the 1/4 of the data that we use for testing, and then print the results of that 1/4 of the data for testing. The other thing you might watch here is, so while I am doing training, you can watch this. While I am doing training, I give both the input and output data, input train and output train, right? But while I am predicting for drawing the model, I only give input train. Why is that? In model.fit, I am giving both input train and output train. But in model.predict, while I am predicting using the model, I am only giving input train as the input. The reason is I am allowing the model to predict the output. Here I am training the model, so I needed to give both input and output because it's supervised learning. But here I am actually predicting the output, so I am just giving the input train. So let me run this model to see how it works. So the name of the file itself actually tells what it's doing: salary regression model using linear regression algorithm. And this program uses frameworks, not just Python, but uses Python frameworks as well. So it's asking me how many years of experience. So let me remove the variable. We will actually check this once again. So we will actually put it back and check it once again. For now, let's go with the default parameters. So it is asking you for the number of years of experience. So let me give, let's say 9.5. It's actually telling me I'm getting a salary of 1,16, rather 116,093 Indian rupees. So if you want to see the model that it has built, so here is the model that it has built. So if you see this, the yellow line is the model that the algorithm has built. The red dots are the training data that you have supplied with the number of years of experience and the salary. And the yellow line is the model that it has built. So one of the shortest ways of understanding how this model has been built is you can actually find out how the model is built in a simple way. Of course, the mathematical way of doing that is you have to actually minimize the error function, which is Jacobian of theta naught and theta 1. That's a very mathematical way of saying that. But if you look at the simple layman's way of understanding how this yellow line is built, the yellow line or the model is drawn in such a way that the average of the sum of the squares of the error is minimized. So let me come again. The yellow line or the model is drawn in such a way that the average of the sum of the squares of the error is minimized. So that's how it is drawn. So if you want to look at a very mathematical way of understanding that, you might have to look at Andrew NG for that. Thanks to Andrew NG for providing this notes. If you go to the place where he teaches, so this is actually the model equation, and this is the Jacobian 1 over 2m sigma I equal to 1 to n h theta naught x of I minus y of I, where this is predicted value and this is the actual value or the ground truth whole square. So if you minimize this Jacobian function, then you can draw the model. So in other words, it is actually saying that the model is nothing but the average of the sum of the squares of the error. Let me run this once again. You can see that the model is the yellow line and the red dots are the input and the output. So once we complete this, we close this and then we find the different salaries for all these different input experiences, which is actually 1/4 of the data that you give for testing. So the different experiences are given and the different salary values for those experiences also predicted by the model. So we have seen a very simple implementation in 7 steps. It's a Python implementation of the simple linear regression on the salary data of software engineers. So it's a simple way of using univariate linear regression, which has one input and one output. Of course, you might be thinking that how can you oversimplify this problem, because the actual prediction of the salary might depend on so many other factors such as number of years of experience, the domain in which he is working, the country and the place in which he is working, and what is how niche his skill level is, how niche the domain is, and then is he at the beginner's level or professional level or at an expert level. So all these things determine his salary. But to start with, to understand the principles of simple linear regression, this model is very handy. So I hope you understood simple linear regression, which is implemented with Python using NumPy, Pandas, scikit-learn, and Matplotlib. The dataset for this problem, which is provided here, you can find it in the link below. And also the program that we saw for the linear regression model is also given in the link below. You might see both the dataset and the problem for you to get a better understanding of the linear regression model. Both of them are given in the link below. Thanks a lot.